Have you ever wondered what keeps a giant factory from just stopping? Or how a hospital makes sure the lights never go out, especially during surgery? Well, the answer is this incredible piece of tech that most people have never even heard of, but our whole world really depends on it. Today, we're going to pull back the curtain on the SIVACON electrical panel. It's the unseen giant of industrial power. Let's jump in.
Just think about it for a second. Imagine a car factory that's churning out a new car every 60 seconds. A power flicker, even for a moment, could cost them millions. Or what about a data center that's handling all our credit card transactions? You can't just have that go down. It's not just an oopsie, it's a full-blown financial disaster. These places are dealing with insane amounts of electricity, and the gear that keeps it all flowing is, as you can imagine, incredibly sophisticated.
So, before we get into the heavy-duty SIVACON, we gotta cover the basics. The easiest way to think about an electrical panel, it's like a traffic cop for electricity. You've got this massive highway of power coming in, and the panel is the one standing there, directing every single electron, making sure it gets exactly where it needs to go safely without causing a massive fiery pileup.
So, what it's really doing at its core is taking one huge, powerful electrical line and slicing it up into smaller, safer, more manageable circuits. It's the central hub, you could even call it the brain, of a building's entire electrical system. It's what makes sure power gets distributed safely to everything, from a tiny light bulb all the way up to a giant industrial robot. Its mission, if you break it down, is a simple four-step process. First, it takes in all that bulk power from the grid. Second, it divides it up into all these different circuits. Third, it protects and controls the flow to each one. And fourth, it sends that power out to all the different loads. And a load is just a fancy word for anything that uses electricity. Your phone charger is a load, and so is a city's main water pump.
Right, but here's the thing. Not all electrical panels are built the same. When you're talking about power on an industrial scale, you need something way more powerful, way more robust. And that is exactly where the SIVACON panel comes into the picture. This is not the little breaker box you have in your closet. This thing is a beast, designed for the toughest, most demanding places on Earth.
And there are some really good reasons why the SIVACON is a top pick. It's designed as modular, which is huge, because it means you can customize it or even expand it as a factory grows. Its reliability is just legendary, which is a must-have when even a minute of downtime can cost a fortune. And even though it's super complex inside, it's actually built to be safe and pretty straightforward to operate, even when things get intense.
And we're talking about some seriously critical applications here. These panels are the absolute backbone of power plants. They're the heart of massive oil refineries, and they're the command centers for huge factories. These are the kinds of places where a power failure isn't just an inconvenience, it's a potential catastrophe.
So, we know it's powerful, we know it's reliable, but what's the real secret sauce? What really sets the SIVACON apart is this brilliant innovation in its physical design. And it all comes down to one simple but crucial difference: a fixed versus a sliding structure. Let's just think through a scenario here. You're in a gigantic facility that runs 24/7. Suddenly, one little component inside your main electrical panel fails. What do? Do you have to shut down the entire operation, stop everything, and lose a ton of money? And this is where the genius of the SIVACON really shines. With the traditional fixed panel, you'd probably have to shut the whole thing down to do a repair. But with the SIVACON's sliding design, you can just pull out the one faulty section. It's kind of like pulling a drawer out of a filing cabinet, while the rest of the system just keeps on running. This is an absolute game changer for any industry where every single second of uptime is critical. This quote from the source material just says it all, doesn't it? The whole design is built around that one single, incredibly important advantage: stopping a total system shutdown. That feature alone is why it's the go-to choice in these high-stakes environments. Okay, so let's pry open the steel doors and take a peek inside. What actually makes this whole sliding design possible? How is this thing put together? The magic behind this whole design comes down to these things called cassettes. The best way to think of them is like Lego blocks for power distribution. Each cassette is its own little self-contained unit that handles one specific circuit. So if something goes wrong, you don't mess with the whole system. You just slide out the one bad cassette, fix it or swap it, and you're back in business without disrupting anyone else. Now, a modular design like this does come with a few strings attached. For one, it needs more floor space than a conventional panel. And it's a lot more complex to put together. This thing is built like a tank from 2mm thick galvanized steel, and instead of flimsy wires, it uses these heavy-duty copper or aluminum bus bars, which are basically superhighways for electricity,
to handle those massive power loads. It is some serious industrial-grade engineering.
So, we've got this amazing high-performance system. But, like any piece of advanced tech, there are always trade-offs you have to think about. And here, it's mostly about cost and the sheer size of the thing.
This table really sums it up perfectly. On the plus side, you get the absolute best in safety, performance, and reliability. But the flip side is a pretty high price tag up front, a big physical footprint, and a very complex internal build. It's a premium solution for problems where failure is just not an option. And that protection isn't just about electricity. See this IP55 rating? That's an industrial standard that tells you this box is built to survive in some really tough places. Basically, it means it's super protected against dust getting inside and can even handle being sprayed with jets of water. So no matter what's happening on the outside, the important stuff on the inside stays safe.
Which brings us right back to the big question. For a hospital, or a data center, or a massive factory, where even just a few minutes of downtime can be catastrophic, we're talking millions of dollars lost. Is that high initial cost worth it? The answer is a loud, clear, absolute yes.
So I'll leave you with this thought. Our modern world pretty much runs on this invisible and honestly pretty fragile network of power. And behind that network, there are these unsung heroes, like the SIVACON, working silently 24/7 to make sure the lights stay on for all of us. So next time you flip a switch, maybe just take half a second to appreciate the incredible engineering that makes it all possible.